Okay, in this question we have a box that contains 4 red and 3 green marbles. Now the question is that 2 marbles are selected or chosen at random without replacement. Remember that without replacement means that once you take a marble, you do not return it back. So we have 5 sub-questions on this. We will solve them each on a separate page. So let's first do the tree diagram. So it says construct a tree diagram and list all the possible outcomes. So our box, it wouldn't hurt to draw the box with 4 red and 3 green marbles, and then you say that I have 2 possibilities for the first draw. I could have red or green. That is the first time you take. You either have red or green. Then for the second time you draw, you either also have a red or green. And here also a red or a green. Now we want on each of these arrows, so before we do the arrows, you see that this would be the situation where you have red first and red second. This situation will be the situation where you have red first and green second. And this situation would be the one where you have green first, then red second, and the last situation will be the situation where you will have green first and green second. Now let's write the probabilities of each of these. The probability of having the red here is, how many reds do we have? We have 4 reds out of 7 balls. And for the green here, how many greens do we have in the box? We have 3 out of the total number is 7. So now let's look at the second draw. And this you need to pay attention. For this red here, it's the second red. So we are assuming that this first red that I have here was chosen already. So it's like it's not there anymore. Okay, so this means how many reds do we have left? 3 out of how many balls left? 6. So this means that the probability here will be 3 out of 6. Similarly, if you want the second one to be green after you choose a red, so again, choosing this red means that 1 red is taken already. So to have a green, those will be 3 greens out of 6 marbles. So you will put here 3 out of 6. And similarly for the green, once you choose a green, let's say it's this one, so you took it out already. So what would be the probability of getting a red next? Look at how many reds are left now. You have 4 out of 6. So you put here 4 out of 6. And the last thing that could happen is that you get a green first. So this one green first, meaning that you chose 1 green already. And now to get another green, that would be 2 left from the greens out of 6 marbles. So I'll put here 2 out of 6. And this would be the tree diagram. Now, if someone tells you to list all the possible outcomes in the space of outcomes, you can say that the space contains red, 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 green, green, red, and green, green. but the tree diagram is important because it's showing you the probabilities on the arrows as you're going with your choices. Now we want to find the probability of getting 2 red marbles. This means that the first choice is red and the second choice is also red. So we want the probability of red and red. So you can actually go back to the tree diagram and see, first you know that probability of the AND probability is you multiply the two probabilities. It's probability of red times probability of red on the second one. So we can make it clearer by saying probability of red first times probability of red second. So we can say red first, red second. That makes it easier. Now, since the box, if you remember, contained 4 red and 3 green, you can say that the probability of first getting a red is 4 out of 7 times. Now, once you have chosen red already, you have 3 reds left out of 6. So it will be times 3 out of 6. And if you simplify, this will be 2 out of 7. So this would be the probability of first red and second red. And remember that this one is without replacement. So that's why I put an X here, because once you choose a red, you cannot return it back. Okay, and now the next question is find the probability of picking the same colored marbles. Same colored marbles meaning that either red red or green green. So this is asking you what's the probability of having red on the first and red on the second, this one, or having green on the first and green on the second. So this will be, since it's an OR probability and these are mutually exclusive events, this is going to be the probability of red on the first and red on the second. It's an OR probability, so you add, plus the probability of green on the first and green on the second. And if you remember, in fact, we have done this one in the previous exercise. If you look back, we got it and it was multiply, of course, the probability. So this would be the probability of red on the first times the probability of red on the second, plus probability of green on the first times probability of green on the second. And this is equal to, let me draw the box again so that you see it easier. So it has 4 red and 3 green. And now remember that red on the first is 4 out of the 7 times red on the second, because we're not returning the first red. Once you took a red, you have 3 reds out of 6. So this will be times 3 over 6, plus probability of green on the first. We have, as you see, 3 greens out of 7. So this will be 3 out of 7 times, once you choose a green, how many greens do you have left? 2 out of 6. So this will be 2 out of 6. And if you do the mathematics, of course, you have to do the multiplication first, and then you do the addition. And the answer to this will be 3 out of 7. That would be the probability of picking the same colored marbles. Now the next question is find the probability of picking a red marble given that the first selected marble is green. So how do we write this? You can say probability of having a red marble second, given that we got a green marble first. Okay? So this is a conditional probability. I still would like to draw the box again so that you see it easier. We have 4 red and 3 green. And so here they're asking us, what's the probability that you have a red ball on the second draw, given that the first one was green? So they are telling you that the first ball that you have chosen is green already. This you know already. So you have chosen it already. Huh? So assume that it's not there anymore. Now what's the probability that the second one you will choose will be red? This would be, how many reds do we have? 4. Out of how many balls now do we have in total? That's 6. So the probability will be 2 out of 3 for this question. It's a conditional probability. Remember that this vertical line here, you read it as given that. Okay? And once something is given, it reduces the total number of outcomes. You see, that's why I took away the green ball, because it says that, suppose that the first one chosen was green. So this is why I assumed that this green was taken out already. This means that we have 6 marbles left, and the probability of getting a red from them would be 4 reds out of the 6 marbles. Now, the last part of this question is a little different. Suppose now that the 2 marbles are drawn with replacement, it says. With replacement means that you take a marble and then you return it back. So the question is, find the probability of picking a red marble given that, so it's a conditional probability, given that the first selected marble is green. So I will write it like this: probability of red marble on the second draw, given that the first one is green. But the difference between this and the previous question is that this one is, as you can read here, it's with replacement. So I will show it to you by drawing the box again. It doesn't hurt to draw the box all the time when you're solving the question, because it makes it easier for you to understand. So again, 4 and 3. And what's given to you is that when we drew first, we got a green marble. So this was the first draw, but what happened is that we got it here, and then we took it and returned it back. So it's kind of like not doing anything. So these events will be independent now, because you returned the green back, and so the situation became the same as if you didn't do anything. So that's why this probability now is going to be 4 out of 7, not 6, 7. This is because this green ball was returned back. And this is something important that you need to remember. When you read with replacement, it means that you return whatever you took back into the box or back into the deck of cards, or whatever the situation is. It means that you bring it back after you take it. And so make sure that you understand why this is 4 over 7 as opposed to why this was 4 out of 6, the previous one that was without replacement. And that is the end of this question.